Hello guys, welcome back to my channel. Today we will be learning about the full subtractor using Verilog code. So what we mean by full subtractor? Full subtractor is a combinational circuit that performs subtraction involving 3 input bit and providing 2 output, that is in a form of difference and borrow. And as discussed earlier, Verilog is the hardware description language. Now let us move on to the truth table for the full subtractor. Since it is a 3 input bit, the first bit will be 0, 0, 0, second bit will be 0, 0, 1, third bit will be 0, 1, 0, fourth bit will be 0, 1, 1, fifth bit will be 1, 0, 0, sixth bit will be 1, 0, 1, seventh bit will be 1, 1, 0, eighth bit will be 1, 1, 1. Now we will do for the difference and borrow here. 0 minus 0 is 0, minus 0 it is going to be 0. So difference is 0, borrow is 0. Now 0 minus 0 is 0. Minus 1 we can't do here because 0 minus 1 we can't do. So that's why we are borrowing 1 here. 1 0 in a binary form is 2. 2 minus 1 is 1. So difference is 1, borrow is 1. Now 0 minus 1 is we can't do. So that's why we are getting 1, borrow here. 2 minus 1 is 1. 1 minus 0 is 1. So difference is 1, borrow is 1. Now 0 minus 1 is we can't do. That's why we are getting 1, borrow here. So 2 minus 1 is 1. Minus 1 is 0. So difference is 0, borrow is 1. Now 1 minus 0. 1 minus 0 is 1. Minus 0 it is 1. So difference is 1, borrow is 0. Now 1 minus 0 is 1. Minus 1 it is 0. So difference is 0, borrow is also 0. Now 1 minus 1 is 0. Minus 0 it is again 0. So difference is 0, borrow is also 0. Now 1 minus 1 is 0. Minus 1 we can't do, so that's why we are getting 1, borrow here. So 2 minus 1 is 1. So difference is 1 and borrow is 1. Now we will do the expression for the difference and borrow. Okay, so this is the truth table for the difference only. Now we will see where we are getting 1 in the T column. We are getting 1 here, here, here and here. We are getting D1 at 4 row. So we will take this row first. A is 0, that is A bar. B is 0, that is B bar. C is 1 means C. For this row, A is 0 means A bar, B is 1 means B, C is 0 means C bar. Now for this, A is 1 means A, B is 0 means B bar, C is 0 means C bar. Plus, now for this, all the 3 inputs are 1, so A, B, C. Now we will minimize these terms. So difference we got as A bar B bar C plus A bar B C bar plus A B bar C bar plus A B C. Now we will take C bar as common. We will get A bar B plus A B bar plus, now we will take C term common, so we got AB plus AB bar. Now this term is inverse of this term, so we can write it as C bar A bar B plus AB bar plus C A bar B plus AB bar. the whole inverse. Now we will take A bar B plus AB bar as X. So we got D equal to C bar of X plus C of X bar. Now this is in a XOR format. So C XOR of X. So what is X? X is A bar B plus A B bar. This is also in a form of XOR term. So the final expression we got is A XOR of B XOR of C. So this is the expression for the difference. Now we will do for the borrow. Okay, for borrow again we will see where we are getting 1 in the borrow column. We are getting 1 here, here, here and here. So we'll take this row first. We are getting B borrow as, for this row, A 0 means A bar, B 0 means B bar, C is 1 means C, plus for this row A is 0 means A bar, B is 1 means B, C is 0 means C bar, plus for this A is 0 means A bar, B is 1 means B, C is 1 means C. And for last, for this row, all three inputs are having 1. So A, B, C. Now we will minimize these terms and get the borrow expression. So we got as A bar B bar C plus A bar B plus C, A bar B C bar plus A bar B C plus A B C. Now we will take A bar B terms common, so we will get C plus C bar. C plus C bar is 1 plus, now we will take C term common, that is A bar B plus A B bar. So we got A bar B plus C. This is in a form of XOR term, so A XOR of B. Now we will draw the circuit diagram for the difference and borrow. First we will write down the expression here. For D we got as A XOR of B XOR of C. For borrow we got as A bar B plus C XOR of B. So since 3 input line means first A input then B input line, for difference it is getting XOR here. So XOR, then it is getting XORed with C. Now for the borrow we will take this term, it is A bar, so from A we will take one line and have a knot here which represent A bar. From B we will take one line here, we'll AND it together, and now this term we will take a line from C, we will take a line from this input line represent A XOR of B. So one small correction guys here, this term is the inverse of A bar B plus AB bar, so it is the inverse here. So here also it is the inverse, and here we'll get a NOT gate here. I'm sorry guys, a NOT gate here. So this is the difference and this is the borrow here. So now This is the circuit diagram for the full subtractor. Now we will implement this in the EdaPlayground. Now we will implement in the EdaPlayground. First we will do the design part here. As set in full adder, we are having two modeling. First is the data flow modeling and the second one is the structural flow modeling. First I will say for the data flow modeling. First we will declare the module as full subtractor and have the input here as A, B, C and output as D, B out. Now we will assign the value here as for D as A XOR of B XOR of C, and for borrow we got as A bar B. So bar represent this symbol represent the bar. So A bar, which is AND with B, and then it was ORed with A XOR of B bar and with C. So here again we will have a bar and A XOR of B, which is AND with C. We will end the module here. Now we will do for the test bench. Before starting the test bench, I will say what is the data flow modeling again. Data flow modeling describes the combinational circuit by their function rather than their gate structure. So now we will do for the test bench. Again we will declare the module name here as full subtractor. Only full sub I am taking here. The module name for the test bench and design should not be same. Now we will have the input as register, which is A, B, C, and output in a form of wire, that is D, B out. Now we will have the design module name here, that is the full subtractor, which we have declared it here. The same we are writing here, and then have the UT, that is the unit under time, which will tell whether the provided input is correct for the output. Input and output we have given as A, B, C, D, B out. Now we will initialize this. Sorry, here it will be dump file and here it will be dump. Small correction. Now we will give the inputs for A, B, C. It is the same input which we have taken from the truth table. So A is 0, B is 0, C is 0 for the first bit. I'm declaring the same here, guys. And then we will have the 10 unit wait time. Then again A is 0, B is 0, C is 1. Then again wait time. A is 0, B is 1, C is 0. 1 0 0, here also 1 0 1, then here 1 0, and here 1. So we have got the 8 inputs here, that is 0 0 0 0 0 1 0 1 0 0 1 1. Okay, this is repeating. Yeah, and then 1 0 0 1 0 1 1 1 0 and 1 1 1. So these were the inputs which we have taken from the truth table. Now we will finish it here. Finish, and then we will end it and end module. Now we are going to make changes in this part. Select 0.9.7 Verilog and give run option as open EPWave after and show output file after, and give output file as full subtractor, the one which you have taken for the design part. Now save it and run. Oh, here. If you do any mistake in the coding here, it will be shown here as any syntax error given, so you can rectify it just like I did right now. We got the waveform for the full subtractor. Now we will do for the structural flow modeling. Okay, now we will do for the structural flow modeling. Before starting on to this, I will describe the structural flow modeling. It is the interconnection between the component of a hardware module and the design of the hardware by connecting various modules and gates. That is, we are going to use wires here. The first part, we have to declare the module. Then we will declare the wire as W1, W2, W3, then A0 and W10. Now first we will do for this gate. For this gate, the input line is A and B, and the output is this line. This line we will call it as a wire. This wire represents A XOR of B, that is representing W1. So we will write XOR, XOR of output. Output is this line. This line we are taking it as W1. So W1 comma input is A comma B. Now for this XOR gate, the input line is this A XOR of B, that is the W1 wire, and the another input is C, which is giving us the output D. So again XOR of D comma W1 comma C. For this gate, input line is A and B. So we have written A and B here, and the output is W1. For this gate, the input line is W1 and C, which we have written here, and the output line is D. Now we will do for the borrow. For the borrow, we are having 3 gates. This one, this one, this one. First we will do for this AND gate. For this AND gate, we are having A as A bar, which is why we are having a NOT gate here. So first we will declare a NOT, that is A is the input line and the output will be A NOT, which is representing the A bar. So NOT output is A NOT comma A. Now for this AND gate, the input line is B and A bar. A bar we have denoted this by A naught, and the output is this line. This line we are denoting it by W2. So we'll write AND W2 comma A naught comma B. Now for this we are having C input line and A XOR of B the inverse. So again A XOR of B we know that it is W1. So W1 it's having a NOT gate here, so that it will give us the inverse. So again we will declare a NOT gate here. So NOT this line W1 NOT. After doing a NOT for W1 we are getting one output that is in a form of W1 NOT, and the input line is W1. Now for this gate we are having input C and W1 NOT, and the output is this line. This line we are denoting it by W3. So and W3 comma W1 NOT comma C, and the W2 line here and this W3 line here are now the output for this OR gate, which is giving us the output as B out. So OR B out comma W2 comma W3. So we did the difference and the borrow, and now we will end the module here. Now I will copy this code and run it in the EdaPlayground. Okay, so I have copied the same code here in the EdaPlayground. Now we will run this. So we got our output waveform, which means that the full subtractor is correct. But the question is how we will know that with the provided waveform our code and the truth table is correct or not. We will see that now. First we will understand how the waveform works. If the waveform is going from low to high, it represents 1. If the waveform is going from high to low, it represents 0. And it is like fully flat and down, that means 0, and it is fully up means it is 1. You can also see here, see from 0 it is going high, low to high it is representing 1, and for here we will see here it is coming high to low, which represents 0, and here it is fully flat in the down, it represents 1, and here it is fully flat and up, that represents 1. Now we will see our truth table is correct for the half subtractor or not. We will see for the input. Here input is 0, 0, 1. For the input 0, 0, 1, we should get difference as 1, borrow as 1. So we are getting difference as 1 and borrow also 1, which means that our code is correct and truth table is also correct. We will check for another one. Here also we are getting A as 0, B as 1, C as 0. For input 0, 1, 0, we should get difference as 1, borrow as 1. And we are getting difference as 1, borrow as 1. We will check for another one. Here, okay, we will check for here. Here we are getting input as 1, 0, 0. For input 1, 0, 0, difference should be 1 and borrow should be 0. So we got. But without using this line, because we are getting 1, 0, 0, 0 here, but we should know how to do it with ourselves. So we will take this part. In this part, A is 1. Here, yeah, we will check here. Here, A is 1. B is for the 60, A is 1, B is 1, C is 0. So for input 1, 1, 0, we should get the output as 0 for difference and 0 for the borrow. Here the difference line where it is, difference line is this. Yeah, difference line is this. For difference it is fully flat, which means 0. Sorry. And for the borrow we are getting 0 also. Here it is fully flat. We will check here. So see, A is 1, B is 1, C is 0, and difference and borrow is also 0. We'll check for another one. We will do for here. Here A is 1, B is 0, C is 1. For input 1, 0, 1, 1, 0, 1, we should get difference as 0, borrow also 0. So difference line is this. Yeah, it is 0 and borrow is also 0. Again we will check here. We should know how to do it manually. That's why I am telling so many examples for you, so that it can make it easier for you to do by yourself. We'll check for here. It is A is 0, A is 1 here, B is also 1 here, C is 1 here. For all the 3 input 1, difference and borrow is also getting 1 here. So that's it, guys. I hope you all understood the full subtractor using Verilog code in the EDA playground.